Now, if potassium and oxygen got into a fight, it would end in a KO. Is that okay with you? Ha! But anyway, it wouldn't actually be KO. It would be something else, and we're going to see what that something else is right here. So, KO. Let's figure this out. Okay? Alright. So, oxygen has how many valence electrons? Look at the periodic table, and you will see that there are 1, 2, 3, 4, 5, 6. Okay. There. Okay, yeah, once again. K, it can give it 1, correct? This can give it 1 electron. Okay. Another K then can come along and give it the second electron. So, what is the formula for potassium oxide? Now remember, the metal is always written first and always pronounced just with its name. The metal is potassium, which is K. How many potassiums do we have? 1, 2, because it takes 2 of these potassiums to balance out the oxygen, or to give it its outer shell. Now if you remember, potassium, I'll go into the real life example next, in case this isn't making sense. But potassium, you have 2 of them. Oxygen is written second because it's a non-metal. But remember, it's pronounced oxide because it's a molecule. You end it with "ide." So potassium oxide is one of them, is K2O. Now, real life example again. Go to Insert, Blank Page. All right. So, the opposite now. You have potassium. Mr. Potassium has a plus charge. Because he has 1 valence electron, he wants to get rid of it, which will make him a positively charged cation. Remember, it's cat ion because there is a plus in cat. Remember, anions are negatively charged because there's an N in anion. They're both ions, one's positive, one's negative. Remember, that can help you. Alright? So potassium's plus 1, oxygen is minus 2. So this oxygen lady, O, that's her mouth going, oh, I get 2 husbands. She gets to marry twice, and bam, on one arm, and another K on the other arm, makes it K2O. Alright? So it isn't KO, it's K2O, which isn't good for the joke, but oh well. Alright, next one. So we already tried MgCl2. But if you name it, it's magnesium chloride. Okay. Sodium oxide. You should be able to do this one now, right? Working backwards, what's the formula for sodium oxide? Alright, so sodium is Na. Oxygen is O. It's oxide, so you know what's the formula. So the valence electrons of Na is 1, so it wants to be plus 1. So you put the 1 there. For oxygen, it is minus 2, so the 2 goes there to balance it out. You don't have to put the 1 there, so exactly like potassium oxide, sodium oxide is written very similarly. Okay. I keep saying okay. Okay. What about transition metals? Their charges are a little bit funky. They don't have this, they don't go the general trend with plus 1, plus 2, skipping a bunch, plus 3, plus 4, and then 0 at the end, minus 1, minus 2, minus 3, for those stable, chemically stable charges. No, they tend to form transition-y, funky charges. But, how do we figure out what that is? Well, if you look at the periodic table, the square for lead is as follows. Pb, it is lead, not to be confused with peanut butter. Because if you get too confused, you might just so happen to have lead poisoning, which is very bad, folks. Make sure that what you're eating is a peanut butter sandwich, not a lead sandwich. You should be able to tell by the weight. Lead's a little bit heavier. In fact, it's so heavy it's 207.2 atomic mass units. It's one of the most heaviest elements in the natural world. That's not man-made. There are a few, but for the most part, of all the common elements, it's one of the heaviest. 82, remember what that stood for? This is the number of protons. Number of protons. Number of protons. Protons are positive because it starts with P. And it has O and a T in it. So positive. I'm positive that's right. So the 82 protons represents lead. Now, if you look at the top right corner, there were some numbers in there. These numbers represent the charge. For sodium, there was only one charge there. It was +1. For magnesium, it was +2. Nice and easy. Those were all trend setters. They set the trends. But the transition metals, think of it this way. All the elements on the side of the periodic table, they're trend setters. They follow the trends of the periodic table. The transition metals is like a transition time when people don't follow the trends. They're like, what do they call them, outcast, or they're trying to be different. They're transitioning into a new stage. They're basically, hey, I don't want to do this. I'm going wherever I want. Lead does that because it's in the middle, all right? Transition metals. So it can be either a +2 or a +4 charge. And I don't expect you to memorize that. That's found on the periodic table. You can look that up. Or you can look at the formula, which is what we're going to do now.